Hey guys, it's Miss Schulman. I'm not using my mouse today, so hopefully there will not be too much clicking. And I'm also trying to talk quieter, so hopefully it will not be as loud, but I can't promise you anything on that. All right, proportional versus non-proportional relationships. We have been talking about proportional relationships, we've been talking about non-proportional relationships, and we're going to finally end this and put it all together. We discussed this a little bit last week or last time we were in school, but we're going to move forward with this and hopefully drive the point home. So let's see. All right. We needed two things in order for a relationship to be proportional. Our first thing we needed was that the y to x ratios had to be equal. And number two was that it had to go through the point 0, 0, or the origin. When we're looking at graphs and trying to figure out if they are proportional or non-proportional, we're going to focus on number two. So let's take a look. This first graph, does it go through the point 0, 0? No, it does not. So it is non-proportional. What about the second graph? Does it go through the point 0, 0? Yes, it is proportional. Graphs are one of the easiest ways to tell whether it is proportional or not. Next, we have equations. Let's go back and look at two equations we've been talking about in this chapter. We started with this chapter with y equals something x. Y equals kx. And through everything we've been learning, we kind of realized that k is really like our m, or our slope. So we could write it as y equals mx. And after we worked with that for a while, we moved on to slope-intercept form, which is that y equals mx plus b. When we watched this video, that the one thing that was different was it had a b. What is that b? That b is our y-intercept. That is where our graph starts. So our graph, that means that it's not going to be starting at the point 0, 0. It is starting at whatever b is. We could, if we wanted to, add a 0 here. It would still be proportional. This represents proportional. And our y equals mx plus b is our non-proportional. But if we added this 0 here, we don't need that. That's extra space, extra work. We don't need it. And because we don't need it, that's why we do not have it for our proportional relationships, because it is always going to start at 0, 0. Let's take a look at these equations. Some of you I know are going to be a little bit confused about a D and a T and a P and an N. There's no Y, there's no X, there's no K or M or B. So what do? Well, we have either y equals mx or y equals mx plus b. Which one does this look most like? Does it look most like our first one or our second one? Good, our first one. That D is really representing our y. And that T is really representing our x. So this guy is proportional. And in this one, our N is really representing our y. And I'm just going to switch the orders. I have a negative 3p and a positive 450, so I just switched the order. This one looks very similar to our slope-intercept form, so I would say this guy is non-proportional. Word problems, our favorite things. The number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14. Y is the number of years and a is his age. Is it proportional or non-proportional? Well, does it look like y equals mx or does it look like y equals mx plus b? Good. Y equals mx plus b, which means it is non-proportional. Not too bad. And last but not least, we have our tables. At the beginning of the year, when we were talking about proportional relationships, we said that y over x, they all have to be equal ratios. So let's see. We have 30 over 2, which equals 15. And then we have 90 over 8. And 8 does not go into 90 equally. It should be about 11 and a quarter. 15 does not equal 11 and a quarter. So this is non-proportional. Let's look at our second table. We have 1 divided by 5, 8 divided by 40, which equals 1 over 5, and 13 over 65, which equals 1 over 5. They all equal the same, so we would say this guy is proportional. All right, before you guys go, here is a organizer that is really helpful. It really breaks it down, the difference between proportional and non-proportional. So I want you right now to pause the video and copy this down. This will be very helpful for homework and classwork. However, I'm going to say now, you cannot use this on tests or quizzes. Sorry, but it will be useful in the near future with classwork and homework. After you finish that, you may look up to the board for your next instruction. See you guys.